Hello all, my name is Hydrogen and today we'll be covering permutation and combinations from additional mathematics 0606. So let's get started. Starting with permutations. First of all, you need to know about factorial. Essentially, it counts full arrangements of n distinct objects. So let's say that you have n objects and you're placing them in 4 given places. So you would fill the first slot with n possible choices, then you would fill the second slot with n minus 1 possible choices since you already chose one object for your first case. Similarly, for your third slot, there would be n minus 2 possible choices and so on. Now, here's the formula for NPR, which is n factorial divided by n minus r the whole factorial, where n is equal to total number of objects, then r is equal to number of objects chosen at once. Now, for this example over here, we're essentially doing n times n minus 1 times n minus 2 times n minus 3, which can also be written as n factorial divided by n minus 4 factorial, which is the same as np4. So, if you compare the intuitive way and the formula, it basically gives you the same answer. Now, permutations are typically used for questions involving arrangement. For example, ABC is a different case from ACB. Permutations is all about arranging n number of items taken r at a time without any sort of repetition. So you're essentially considering all favorable outcomes while keeping the order into account. Now moving on to combinations. Now combinations counts ways to choose r items from n objects without regard to order. For example, the selection ABC would be the same as CBA since the order doesn't matter. So now I've given an example over here. In this case, we are picking two fruits from these three given fruits. So since you're choosing two fruits from three, using the formula, it would be 3C2, which would give you three cases. If you ignore the formula for a while and just write out all the possible cases, it could be apple plus orange, or apple plus pear, or it could also be orange plus pear. These are your three cases. Now this skips rearrangement since order doesn't matter over here, unlike permutations. So for combinations, the case ABC would be the same as BAC. This is where the combinations formula comes from. NCR is basically equal to n factorial over n r factorial times n minus r the whole factorial. And if you observe closely, it's actually related to NPR. Now, you can use combinations as well when it comes to arranging objects, but you might have to do some additional operations, such as using factorial, so that you can select the objects first using combinations and then you can arrange them using factorial. So, for example, if the order did matter for the given case, since you're choosing two fruits, there would be two factorial ways to arrange those two fruits. Hence, you would do 3C2 into 2 factorial for permutations. So, if you were to write down all the possible cases, you just consider all these combinations, write them down over here, and since you're considering all the arrangements as well, it could be, for example, apple plus orange, or also orange plus apple. That ends up giving you 6 possible cases for permutation. Now, moving on to the syllabus document. This is everything that you're expected to know from your 0606 syllabus for permutations and combinations. So let's get started with some questions. So you're told that a 4-digit number is to be formed using the digits 0, 2, 4, 5, 6 and 8. And one thing to keep in mind is that the 4-digit number must not start with 0. So any digit may be used at most once in the 4-digit number. Now you have to find out how many 4-digit numbers can be used. One thing to keep in mind is this clearly stated that any digit may not be used more than once, which means you cannot repeat that digit. So first of all, just make a rough diagram of those 4 digits. Now you cannot start with 0. So if you're looking at the first digit, you automatically exclude 0. So you're left with 1, 2, 3, 4, 5. 5 possible digits. Now, if you look at the second um, place, you can take 0, you can take 4, 2, 4, 5, 6, 8. However, in the first case, you select a number from these given numbers. That means there would be 5 possible numbers to choose from once again. Then you'd end up with 4 possible ones and then 3. So calculating this gives you 300. Now, find how many even 4-digit numbers can be formed. So once again, make a rough diagram. Now, again, you cannot start with 0, so make sure you keep that in mind. Now, if it's an even 4-digit number, it can either end with 0, or it can end with 2, or 4, or 6, or 8. Now, you would have to consider multiple cases for this. Let's say that um, it does end with 0, for example. In that case, you're left with essentially 1, 2, 3, 4, 5. So you're left with 5 possible digits to fit into these 3 um, remaining places. So that would be 5p3 when you consider only 0. The second case is when you're considering 2, 4, or 6, or 8. Let's say you consider, for example, 2. Now, you could consider each and every digit separately, but the faster way is that you just multiply it by 4. So there are 4 possible digits that you can choose over here. Now, obviously, you're left with 5 digits over here once again. However, this first digit cannot start with 0. So you can only have 4 digits over here. Now, you can have 0 again over here. So you're left with 1, 2, 3, 4, 5, 6. 6 minus 2, which is 4. So you're left with 4 digits, and that times 3. So these are your two cases, and if you add them up, you end up with 252. Now you have to find out how many 4-digit numbers that are divisible by 5 can be formed. So 1, 2, 3, 4, 5. Now, if it's divisible by 5, it can either end with 0 or it can end with 5. Now you have two cases once again. If it ends with 0, you can have essentially 5p3 for these 3 remaining places, or if it ends with 5, so there's only one possible case. Now this can't end with 0. Sorry, this cannot be filled with 0. So you're left with 6 minus 2, which is 4. And now 0 will be considered over here. So you're left with 4 again and 3. So Now you have to solve the given equation. For these type of questions, it's always best to cancel things out because that saves you a lot of time. So first of all, just make use of the formula NCR is equal to n factorial over n minus r factorial divided by r factorial, which would give you n plus 1 times n plus 1 factorial over n plus 1 minus 12, which would be n minus 11 factorial divided by 12 factorial is equal to 33 times n minus 10 times n factorial divided by n minus 10 factorial divided by 10 factorial. Let me just take this down. Now, what you can do is cancellation. So first of all, you know that n plus 1 factorial can be rewritten as n plus 1 times n factorial. So you can cancel out this and this, which ends up giving you n plus 1. Similarly, you know that n minus 10 factorial could be rewritten as n minus 10 times n minus 11 factorial. So you can cancel out n minus 11 factorial from both the sides. Again, you have 10 factorial, so that can be cancelled out to give you 12 times 10 because, sorry, 12 times 11 because 12 factorial is just 12 times 11 times 10 factorial. This, so that makes a bit of sense. Over 12 times 11 is equal to 33 times n minus 10. Oh, right, sorry. We cancelled this out to n plus 1. So you're left with n minus 10. Now you have n minus 10 and n minus 10, so you can cancel that. So you're left with 33 on the right hand side. Now you could expand this to give you a quadratic, but if you just take the square root on both the hands, or sorry, both the sides, you end up with n plus 1 is equal to square root of 30. Root of that would be 66. So you get n is equal to 65. That's your final answer. Now, in this case, you're told that a team of 6 people is to be chosen from 10 people. 2 of the people are sisters who must not be separated. Find the number of different teams that can be formed. So, you're first of all choosing 6 people from the given 10 people. Now, you have to find the different teams that can be formed. So there are two cases over here. Either you can have both the sisters, and another case when you don't have both the cases. Sorry, both the sisters. So just consider the case where you do choose 2 sisters. When you do that, you're left with 4 people to be chosen from out of 8 people because you already chose 2 people, so they are fixed. You don't have to worry about them. Now you just have to worry about the remaining 4 people that you're choosing. So that would be 8C4 plus when you don't choose those 2 sisters. So you're basically excluding them. So it's the same as choosing from 8 people, but choosing 6 people out of 8. So that would be 8C6. Now, adding that up, would give you 98. Now moving on, you're told that a 6-character password is to be chosen from the following characters. No character may be used more than once in any password. Now find the number of different passwords that may be chosen if there are no restrictions. So again, you cannot choose a character more than once, so you have to keep that in mind. Now, since there aren't any other restrictions, you have to choose 6 characters out of 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can simply do 9p6 gives you 60480. So you're told that the password starts with 2 letters and then ends with 2 digits. So just make 6 gaps first of all. Now these two would be for letters and then these two would be for digits. So since you're choosing and arranging 2 letters, you can simply do 3p2. Similarly, for the 2 digits, you can do 3p2 as well. And then you chose 4 digits out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So since you chose 4 out of 9, you're left with 5 digits. And you have to choose and arrange 2 digits out of 5. So you would multiply this with 5p2, which ends up giving you 720 ways. Now, moving on, you're told that Mark chooses 5 people from 4 men, 4 women, and 2 children. And you're told find the number of ways that Mark can do this if there are no restrictions. So there are in total 4 plus 4 plus 2, which is 10, and you're choosing 5 out of 10 people basically. So that would give you 252. Now, moving on, you're told if at least 2 men are chosen, and your Mark is choosing 5 people, right? So, there could be either 2 men, or there could be 3 men, or there could be 4 men. Not more than that, because in total there are 4 men. So, you consider all the possible cases of men because you're told at least 2 men are chosen. So, just write down all the combinations of that. So, that would be 4c2 times you're left with 4 plus 2, 6 people to choose from. So 6c3, that plus 3c, sorry, 4c3 times 6c2, because as the total number of men that you choose increase, the total number of other people that you're choosing decreases. Then you have 4c4 times 6c1. Now, adding all of this up would give you P186. Moving on, we come to part C, which is if at least one man, at least one woman, and at least one child are chosen. And you could either consider all the cases where you choose, for example, one man, one woman, one child, and then, for example, some other number of remaining people, or you could also do total cases minus the case where there are 0 men plus the case where there are 0 women plus the case where there are 0 children. Now the reason this works is because of complements, complement events. Now, essentially, you're considering the case where there are zero men, so that means it obviously does not satisfy this requirement. The same goes for these two as well. So, you're considering all the cases apart from this given requirement out of your total cases. So if you subtract those cases, you would end up with the remaining ones, which would be for these cases. So as we already calculated, without any restriction, there would be 252 minus the case where there are 0 men. So in that case, you would be left with 6 people, and you would do 6C5, which is the same as 6C1, so that would be 6. That plus the case where there are 0 women. So once again, there will be 6 cases for that, plus the case where there are 0 children. When you're left with 4 men and 4 women, so you do 8C5. 8C5 would be equal to 56. You should end up with 184, and that's all. Now moving on to the next question. A committee of 8 people is to be formed from 5 teachers, 4 doctors, and 3 police officers. You're told to find the number of different committees that could be chosen if, first of all the 4 doctors are on the committee. So that means you're already fixing 4 doctors. Let me just make a rough diagram of this. Keep in mind that since you're choosing, the order won't matter for this. So doctor, 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 doctor. Now you're left with 5 plus 3, which would be 8 people to choose from, and you just have to choose 4 places for them. So it would just be 8C4. Now 8C4 would be equal to 70. Moving on to part 2. We told that there can be at least 2 teachers. So since you're saying at least, there could be either 2 teachers, or there could be 3 teachers, or there could be 4, or there could be 5. Let me just write it like that. So that would mean for the first case, you would choose 2 teachers out of 5, which are the total number, multiplied by the remaining. So you're left with 6 people to choose from out of 7. That would be 7 choose 6. Which would be 70. Now I'll just show the working for all the cases first, and then we just calculate it at the end. Then when you choose 3, that would be 4C3 times 7C5 plus 5C4 times 7C4 plus 5C5 times 7C3. Now if you add all of this up, you would end up with 490, which is the correct answer. Moving on. Now you're given that NP5 is equal to 6 times n minus 1 P4. You have to find out the value of n. So using the formula for NPR, which is equal to n factorial over n minus r factorial, you can rewrite this entire given equation. So that would be n factorial over n minus 5 factorial is equal to 6 times n minus 1 factorial divided by n minus 1 minus 4, it should be n minus 5 factorial. So notice how you can just cancel these two parts right away, and just keep in mind that n factorial can be written as n times n minus 1 factorial. So you can cancel this and this out to give you n. Hence n is equal to 6, which is your final answer. Now moving on. Let me just shift this downwards. So it told that a family has 5 sons, uh, 4 daughters, and there are 2 parents. Now all 11 members of the family play tennis, and 6 members of the family enter a tennis competition where teams consist of 4 males and 2 females. Now you have to find out different teams of 4 males and 2 males that could be selected if there are no further restrictions. So what are the total number of males? You have Mr. Goldicott, then you have 5 sons, right? So that would be 5 plus 1, which would be 6 males. And for females, you have Mrs. Goldicott plus 4 daughters, so 5 females. Now that would mean you're selecting 4 out of 6 objects, so 6C4 times 5C2, which would be equal to 150, which is the right answer. Now you're told that Mr. and Mrs. Goldicott must be in the team. So you're selecting how many people? 6. 1, 2, 3, 4, 5, 6. And you're placing these two objects or these two people beforehand. So Mr. and Mrs. These two are fixed. So you're left with 4 more people to choose from out of 6 minus 1 and 5 minus 1, because there is one Mr. and there is one Mrs. So in total there are 5 males remaining and 4 daughters. Or you can think about it as there are 5 sons and 4 daughters. Another thing that you have to keep in mind, that you're technically choosing 4 males and 2 females. So make sure that before diving into the question, you actually check whether this is a part of I or it's like a part of the entire question. And since this is a part of the entire question, you have to keep this in mind. There are 4 males and 2 females, right? So you're left with 5 sons. You already selected one male, right? So you just have to select 3 more. So that would be 5C3 times, you have to select 2 females in total. You already selected one, so 4C1. Now that would give you 40, which is the right answer. Moving on, I'll just take this downwards. Now you're told that either Mr. or Mrs. Codicott are in the team, but not both. So 1, 2, 3, 4, 5, 6. In total, there are 6 males, and in total, there are 5 females. And the restriction or the condition is there have to be 4 males and 2 females. So 4 males, 2 females. Now, in the case where you kind of select Mr. Goldicott, you have to just select 3 more males, and you do -1 because you already selected a male. Now, another thing to keep in mind is that both of them cannot be in the same case. So that means when you select Mr. Goldicott, for example, you have to exclude Mrs. Goldicott from the females as well. So you will be left with 5 males and you'll be left with 4 females actually. So you already selected one male, so you just have to select 3 more, and you're left with 4 because you have to exclude Mrs. Goldie. That would be 4C2. Now similarly for this, when you select Mrs., so you're left with 4 females, and you do -1 from males because you have to exclude Mr. Goldie. So you already selected a female, so you're just selecting 4C1, one more female, and then 5C4. This gives you 60, and then 4 into 5 would give you 20. If you add that up, you'll get 80, which is your final answer. Next, moving on to the last question in permutation and combinations. You're told that a lock can be opened using only the number 4351. Now you're talking about a lock, okay? Just keep that in mind. You have to state whether this is a permutation or a combination of digits, giving a reason for your answer. So this is clearly going to be a permutation because the order matters for a lock. Moving on, there are 20 numbered balls in a bag. 2 of the balls are numbered 0, 6 are numbered 1, 5 are numbered 2, and 7 are numbered 3 are shown below. Now 4 of these balls are chosen at random without replacement. That means when you choose a ball, you're not putting that back into the bag. Once you choose that ball, it's gone forever. So the total number of balls remaining in the bag decreases by 1. Now you have to calculate the number of ways this can be done. So that, first of all, you have that the 4 balls all have the same number, which means the minimum frequency for those balls have to be at least 4. So you obviously exclude 2. So you look at 6, 5, and 7. So starting with that, you can either do 6C4, or you could do 5C4, or you could do 7C4. Basically selecting 4 balls from the given frequency. 6C4, 5C4, 7C4, which would be equal to 55. Now then you're told that the 4 balls all have different numbers. Now there are clearly 4 different numbers on the ball. See, so you would select one from each of them. That would be 2C1 times 6C1 times 5C1 times 7C1, which is the same as 2 times 6 times 5 times 7, which would be equal to 420. Moving on to the last question. You're told that 4 balls have numbers that total 3. So it could either be, you have to consider all the cases in which the sum is equal to 3 essentially. So it cannot be 0, 0 and 3 or something because you're selecting 4. It could be 1, 1, 1, 0, right? So you could do 6C3 for that times 2C1, 2C1. Then you have the case where you could do 2, 1, 0, 0. So you'd select 1 from 2, 1 from 6, and then 2 from 2. So that would be plus 5C1 times 6C1 times 2C2. Is there any other case? Um, is there anything else? Wouldn't be any other case. These are the only two possible cases. So you'd add this up to give you 70. And then that's pretty much it for permutation and combinations. Thank you for watching.